So, exponential growth and decay is what we're going to talk about here. And here's my pen. Alright, so for exponential growth and decay, it's going to be of the form y equals a times b to the x power. And in this equation, your a is always going to stand for your initial, oh gracious, initial or starting amount. The b value is your growth or decay factor. And x is always going to be some sort of time. Now, it might be time that we actually use a lot, things like hours, days, years, months, something like that. It also can be like an unofficial sort of time. For example, one thing I can think of that it would be kind of a weird sort of time would be you could use one of these equations for the number of teams left in a tournament. So if you have like a single elimination tournament, you could write an equation that'll tell you how many teams are left. So the time in that wouldn't necessarily be like a day. It would be the round of the tournament, which might be irregular periods, right? You might go 2 days without a game, and then you might have 2 rounds in 1 day or something like that. So it can be something sort of irregular like that. Most of the time, it's going to be a unit of time that we actually use. So, all right. So if we have growth, the b value is going to be 1 plus our growth rate as a decimal. If we have decay, it's going to be 1 minus the decay rate, also as a decimal. Just to do a quick example, if I have 5% growth, then my b value for that would be 1 plus, what is 5% as a decimal? 0.05. 0.05. If we want to change something to a decimal from a percentage, we just take wherever the decimal is. If there's not one, it's at the end. Move it to the left 2 places. It's the same as dividing by 100. Percent means per 100, so it's like dividing by 100. So in this case, you'd get 1.05. If I have a decay rate, so let's say we've got like 3.2% decay, then for the b value, I would do 1 minus my rate as a decimal. So I'd move that decimal 2 places to the left, fill in with 0.032, and that would give me 0.968, I think. Is that right? I think so. Double check. Okay. Questions so far? All right, let's look at some applications. So, these are about the first real word problems that we've looked at. I guess some of the ones where we're asking about shifting are word problems, but we're looking at different instances where you might have exponential growth or decay. One of the first things that we're going to talk about is the growth of an investment. A lot of times investments are going to grow in an exponential manner. In fact, like if you go put your money in a savings account, it definitely grows in an exponential manner because that's just the way they're set up. Something like the stock market has a lot of variability to it, so it depends on what's happening there. So the original value of an investment is $1,800. If the value has increased 7% each year, write an exponential function to model the situation. Then find the value of the investment after 15 years. So we are going to do y equals a times b to the x. What is my a value here? What would be my starting value? 1,800. Okay. Then I have to find my b. Okay. We are going to use 7%. But for the b value, is this growth or decay? It is growth because we are increasing, right? So that's growth. So we're going to do 1 plus, and we have to add the 7%, but we have to make it a decimal. So Adriellis, what is 7% as a decimal? 0.07. So that means we're using 1.07. Do you guys remember the other day on the Real World Wednesday that we did on Thursday, where we were doing sales tax and it was 7%, and my shortcut was to multiply by 1.07. That's the same thing that's happening here. You got the 1 is the 100% that you got to pay. You have to have, you're keeping 100% of your money, and the 0.07 you're adding to it. That's the extra that you get to keep. So for each one, I would highly suggest that you do what I'm about to do. I bet a bunch of you won't do it, but this will help you some when you get to problems like number 2. X, what does it represent? What does it stand for in the problem? The years. Okay, what does the Y represent in the problem? How much money we have total. So it could be total. I'm going to use this word balance. Okay, that's usually what we call the amount of money you have in an account. You can also use like maybe value. Would be another good word for it. So if you don't write this down, you at least need to think about it, because there's usually going to be another number in the problem that you're expected to plug in. In this case, it's 15. Where does 15 go? X or Y? Okay, it is 15 years. Years is X. So we're just going to plug this in for X. So we'll have 1,800 times 1.07 to the 15th power. And so if we grab our calculator or Desmos, either one, calculator. Let's set this up over here. Okay, so if I use my calculator, let's get rid of that. Right there. Away. Alright, if I use my calculator, I'm just going to type in 1,800 times 1.07 to the 15th. I don't have to do anything special. I'm going to get Y equals $4,966, and we're going to go 26 cents. Since this is money, we'll stop at 2 decimal places. So, if you had $1,800, put it in a savings account. Actually, that's bad. You're probably not going to get 7%. in a savings account. But you might get 7% in a different type of riskier account. So after 15 years, it would turn into almost $5,000. So it's pretty decent return there. Okay, questions on that? All right. 2 is going to be set up the same way, but the way we solve the problem is going to be different. Okay. So in 2002, there were 972 students enrolled at Oakview High School. Since then, the number of students has increased by 1.5% each year. The school was built with a capacity of 1,050 students. In what year will the high school first exceed its capacity? So we're going to set this up like we did the other problem. Rylan, what's my starting value for this one? 972. That's the number of students that I have at the beginning. I need to find my B value. Okay. Peyton, are we looking at growth or decay? Growth, because we are increasing. So I need to do 1 plus. Anna, what is 1.5% as a decimal? Okay, so when we want to change something to a decimal, we're going to take our percentage, we can take wherever the decimal point is, we move it 2 places to the left, we fill in any blank spots with zeros. So it's going to be 0.015. Another way you can do it is to divide by 100, because a percent means per 100. So if you divide by 100, you'd get that same value there. So we get 1.015. That is our B value. Okay, we're going to put the X up there. Now, just like the last problem, I'm going to write this down. X, what does X stand for on this one, Miles? It is definitely time. That's true. What kind of time for a number 2? Year. And specifically, when did we start here? 2002. So it's the number of years since 2002. Right? It's not our, like, if we get 5 as our answer, that doesn't mean the year 5. Right? Or if we get 15, it doesn't mean the year 15. It means 15 years since 2002. So that might be important at the end there too. And Y, okay. Lily, what does Y represent here? Yes, population of the school. Population, or we could say number of students. Okay, so all these problems are going to have information. You're going to write yourself an equation. I highly suggest listing what they stand for. Then there's going to be an extra number that you're going to need to plug in somewhere, that 1050. Where do I put it? It goes for the Y, which makes this problem different than the last. Setup is the same, right? We set up the same, but I know that this 1050 needs to go for the Y because it's students. And Lily told me that Y is the population, the number of students of the school. So that means I've got 1050 equals 972 times 1.015 to the X power. Now we're going to check our work using Desmos, but sometimes the numbers are big, so sometimes it's a little hard to find on the graph. So I want us to be able to solve this by hand as well. So if I want to solve that equation right there by hand, now in Math 1, the reason this is here, even though you've done a lot of this, in Math 1 you could not solve that equation by hand. Okay, but now we should know how to solve that equation by hand. In fact, it might not even be all that difficult, hopefully, once you see a couple of these. So, if I want to solve this by hand, what should I do first? am going to have to log, but not yet. What do I need to do before that? Yes, we need to divide by 972. Because we were trying to get everything away from that x, and this number is multiplied by that number, so we got to divide to get rid of it. So in my calculator, I'm going to do 1050 divided by 972. I'm going to get some crazy big decimal. So I've got 1.080246914 equal to 1.015 to the x power. I would not round on these because if you round, the error is going to grow exponentially just like the equation grows exponentially. So if we're plugging in bigger numbers, it's going to be way off sometimes. So I would not round. Now what should I do? I got to get rid of the 1.015. How do I get rid of that? This is where I log it, right? Because this is 1.015 raised to the power. So to get rid of a base of an exponent, we do log base 1.015. That'll cancel that out over here on the right side. We will do log base 1.015 over here as well. So we would have our x is going to equal log base 1.015 of 1.0802469114. And when you type this into the calculator, if you use your should not have done that. Okay, there it is. So if you type this into the calculator, here is a trick for you. If you do log and you don't have to type in that big long number right there, if you do second and the negative key, it'll put the answer from the line before there. So you don't have to copy the whole thing. Or type in the whole thing because you don't want to round these off. Sometimes it'll make you way off if you do. And then we'll do log of 1.015. Excuse me, I'm getting x equals 5.184. Now, the question, though, says, in what year will the high school first exceed its capacity? So it's 5.184 years, but that is not giving me, like, the year that it is going to happen. What year would this happen? During 2007, right? Because this is my years, this is years since 2002. So it would just be 2002 plus the 5 years. We got a 0.184, but that just means it's going to happen during the year, maybe about March. So we'd get 2007, during 2007. You can see why this would be important to study, because whenever I looked at this question the first time, 1.5% growth does not seem all that high. So that the answer was a little bit surprising to me. It was quicker than I thought it would happen. So this school right here would be 5 years away from running out of room in its classroom. So it would need to be coming up with a plan for this to have enough room for all the students. Especially if they believe that growth is going to be sustained. Every year there's a little bit of fluctuation. Some years you have a few more kids, some years you have a few less kids. But if they were seeing growth in their area, then they would need to plan for that. We're a little bit high. The elementary school's like pretty full. I think they had to turn away some out of district kids this time. So I I think we're a little bit high right now, but I don't think overall we've really seen, like, it's been, you know, it goes up and down, but I don't think it's been super high. I don't think Elkin's really seeing like a population growth right now, but I don't know if there's a decline either. So in general, in our whole state, rural areas are seeing a little bit of decline, and cities are seeing an increase. In North Carolina. Now, some places, cities are seeing, like, there are some cities where you're seeing a lot of decrease. There's several in California that are decreasing population. But monitoring population is really important because whenever you're looking at building roads, building schools, building, you know, all this stuff that costs lots and lots of money, you need to be watching the trends of what is happening so that you plan accordingly. And in bigger places, it's even more important. The likelihood that we have, 5,000 people move to Elkin within the next 5 years is very low. It'd have to be some sort of huge business or something come in for that to be the case. But the likelihood that Raleigh has an extra 5,000 people, probably half, or more in the next little bit. Okay, now let's talk about some decay. All right, so let's say we have an investment that we have $12,000 that's losing value at a rate of 4% each year. Now, does anybody put their money in an account that they know is going to lose 4% per year? Not if you know it's going to happen, right? But what could you put your money in where it might lose 4% per year? Stocks, right? Is anybody in the, what's the class? I think it's mostly seniors that are taking it right now, but the financial class, Coach Blevins is teaching it. What is it called? Maybe, is it like, I thought there was something else in the name. No. It's a new requirement. Yeah. I think seniors are taking it right now. Anyway, I've got several of my seniors are talking about their stock market in that class. Like, Coach Blevins has them, like, in some sort of simulation where they got money. Marley told me that, she's not a senior, but Marley apparently is in it. Marley told me that she's lost $35,000 already in the stock market. Thankfully, this is simulated, not real money. But stock market can go up and down. So while nobody's going to tell you, hey, let me have $12,000, it's going to lose 4% per year, it might happen in the stock market. Now, if you go put your money in a savings account, that won't happen. Savings accounts don't have that variability. But savings accounts also don't get nearly as good of interest rates because of it. So we're losing 4% per year. So our equation will look like this. We'll have $12,000 will be our A. For our B value this time, since we are losing 4% each year, we need to do 1 minus. Sawyer, what is 4% as a decimal? Very good, 0.04. So if we do 1 minus 0.04, we will get 0.96. And that is our B value here. And we'll raise that to the x power. X is our time. In this case, we're talking about years. And Y, in this case, what would that represent?
Interest rate?
It's not your interest rate, because the interest rate is staying the same. It's the value of your investment. So the value or the balance in the account. So we have a number down here. We got a 9. Where does that 9 need to go? X or Y?
Correct.
It is years. X is years. So we're plugging it in for our X. So we're going to have Y equals 12,000 times 0.96 to the 9th power. We're just going to type that into the calculator over here. and we will get $8,310.41. So, it did take 9 years, but lost almost $4,000. Now, what got us so off track in second period, it might happen here too, is example 3. That'd be like stocks. And that is this 4% each year. That would be like an average that you would see over time. You would not know it was going to go down 4%. You would put your money in an account, and you would hope it goes up, but it might go down, right? Whenever you do anything based on the stock market, it can go up and it can go down. So, I mean, you could buy like stock. You could be like, I'm going to buy some TI calculator stock. I wouldn't do that. I think Desmos is going to overtake it soon. But you could buy stock, and it might go up, it might go down. Another thing you can do is you can put your money in a mutual fund. Mutual funds is not putting your money in a single stock. It is putting your money in like a group of stocks. So it might be a little bit of this stock and a little bit of that and a little bit of another. And what it does is it follows the market a little better. So your TI stock might not be doing great, but your Walmart stock might be doing pretty good. And so overall, it's going to be a little bit safer because you're not putting all of your eggs in one basket. It's also probably not going to be as good as if you could have went back and put your money in Amazon when it was still just selling books, or if you could have put your money in something like Apple or Microsoft back before it even got started, you'd be in good shape these days. But the stocks, can go up and down. Mutual funds are going to go up and down as well, but they're going to be a little bit more steady. Most people's, whenever you have like money in a 401k or a pension, that is based on stocks as well. Although pensions are a little better because they guarantee you payouts. It just hurts people coming behind you. But that sort of stuff is going to be based on that, and that's where you might see this happening. Now, number 4. So stock market, you might make money, you might lose money. I can't guarantee anything on that. I would warn you, don't just go put a bunch of money on the stock market if you don't know what you're doing. You probably might. There's been lots of people lose a lot of money by doing that. But my big warning comes with example 4, because almost everybody is going to buy a car in their life, especially living in Elkin, a rural area. You mostly need a car. It is difficult to walk, right? Like you could do it. You would need to work very close to wherever you live. You would need to live somewhere near a grocery store. It would not be easy to not have a car living in a rural place like we live right now, right? There wouldn't even be a really good place that you could live where you could walk safely and easily walk to school and the grocery store and somewhere to work all at the same time. It would be a little difficult. The grocery store is what would get you. We don't have a grocery store very close here. I guess if you went to like Combs and Farmers Market and stuff and didn't go to Food Line or Walmart or Ingles, you might be all right. But you could do it. Wouldn't be super easy. So most of us at some point in our life are probably going to buy a car. And cars, everyone needs to know, are not good investments. I don't care what you buy. The only type of cars that are going to go up in value are cars that are collector items. And they don't do you any good because all you can do with a collector item car is sit it in the garage and rub on it a little bit and maybe take it out every once in a while to show it off and then put it back in the garage right away and rub on it a little bit more, right? Because if you have a collector car and you drive it, it's still going to lose value because it's not going to be in as good a condition as it was before. Now, you might need to drive it a little bit so it'll stay running, but if you drive it to work every day and it's getting hit by bugs and gravel and all kinds of other stuff, it's going to also decrease in value. So, aside from some collector cars, on average, cars are always going to decrease in value. They are not, if you are driving them, they are going to decrease in value. Now, we are coming off of a really weird time where during COVID there were a lot of car shortages, and there were actually some used vehicles that were increasing in value. So it was a strange time. That stopped some, although we're not quite back to where we normally would be. There's still some little bit of crazy used car prices, but in general, barring something really strange, cars do not go up in value. There might be just a little blip where it goes up for a little bit, but it's coming back down. If you're driving that car, you're wearing it out. It's got less life left in it. It is not an investment. So, if before you go spend, I think Marley told us earlier that the newest red Cadillac Escalade that she was wanting was $154,000. So before you go decide that you're going to drop $154,000 on a vehicle, which is almost exactly what I think we paid for our house several years ago. Now, prices have gone up. I don't know, it's probably worth more than that now. But before you go drop the kind of money you could buy a house with on a vehicle, you must understand it is not going to keep its value. It is going to go down, and it goes down pretty quickly. The moment you drive it off the lot. If you go buy a $154,000 Escalade off the lot, it might lose $15,000 as soon as you leave the lot. It's probably something crazy. Just because the percentage that it's going to drop is going to be so much because it costs so much money. Sometimes I'm amazed in Carline how many of those things, not Escalades necessarily, but those big SUVs, yes, there's tons of them. And, of course, they're not all brand new, and they're not all necessarily ones that cost $154,000, but there's still a bunch of them. But if you buy a vehicle, it will decrease in value. One thing you have to be careful of when you buy a vehicle is what we're going to see is it's going to drop a lot at first. Okay, so let's write our equation for this, and then we're going to look at the table a little bit, and then we're going to answer our question here. Then we're probably going to run out of time. We're about exactly the same place we were in second period. So we got $35,000 is our starting amount. So, if you're buying something new, that's not a super expensive something new. Some stuff is crazy these days. We are depreciating, meaning that we're going down in value. So our B value, we'd have to do 1 minus, we'll do 1 minus 0.08, which will give us 0.92. And really, 8% is not that bad. 8% is pretty good. So I'm going to put this into the table. I'm not going to have you guys do it. I think I've already, no, I changed that. 0.92. If your vehicle is only depreciating 8% per year, you're in pretty good shape. It's holding its value pretty well. But this $35,000 car, you can see I put it in the table here. After a year, it's only worth $32,200. And then after 2 years, $29,000. And 3 years, $27,000. Now what you'll notice is here this first year it's dropping like almost $3,000. If we go down here to like when it's 15 years old, at 15 years old it's worth $10,000. At 16 years old it's worth $9,218. It only dropped $800 that year, right? It only lost $800 worth of value. But when it was brand new, it lost almost $3,000 worth of value. You're going to lose more in the beginning and less as it goes on. So if you have a, 1998 Camry that you drive, it's probably not going to drop all that much. It may still drop some, but it's not going to drop all that much. You might lose, $200 or $300 off of the price in a year. But if you buy a brand new something, it's going to drop a lot more. What you got to be careful of is if you buy something really expensive, and especially if you don't have a down payment, and you and you stretch out your loan a long time, like 8 years. People do this on trucks a lot because trucks cost a ridiculous amount. And they'll do like an 8-year loan on a truck and they won't pay a down payment. You can get upside down on the loan. Have you guys heard about being upside down on a loan before? It means that you owe more money for that car than it is worth. So you might still owe, it's dropping so fast at first, you might owe the bank $90,000 for your brand new truck that you decided you needed to have. You might owe the bank $90,000, but because it's dropping so fast there at first, it might only be worth $85,000. So what happens is if you total that truck, if you wreck it beyond repair, the insurance company does not pay you what you owe. They pay you what the vehicle's worth. So they will pay you they'll pay the bank the $85,000, and you will still owe the bank $5,000 more for a vehicle you don't even have anymore. You'll just be paying off your debt for that. So, we've ran out of time. We will finish this up tomorrow.